Hey everyone, today I'm just going to explain how to factor a difference of cubes and a sum of cubes. So a difference of cubes and a sum of cubes are expressions that are of the form x cubed minus y cubed. So essentially you're subtracting off two cubes there. And a sum of cubes would just be x cubed plus y cubed. So this is actually related to a question that I assigned a while back, and it was on page 103, number 12. And even if you didn't do the question, we can just look at it now and hopefully we're able to spot a pattern that we have when we try to factor a difference of cubes. And we will follow the same format for a sum of cubes. So in the question, it asked you to factor this expression here, x cubed minus 8. So going back to the basics, if I ask you to factor a polynomial function like this, there is no easy shortcut going back to grade 10 material, but we know that we can find the zeros first. So using the factor theorem, I hope it's clear that x, if I sub in x is equal to 2, this will give me 0, which means that it is one of the zeros. And using the factor theorem, I know that I can then factor out x minus 2. So I'm not going to do this next part for you, but if you use long division and you do all the work there and you complete it out, you're able to factor this expression right here as x minus 2. And then we have x squared plus 2x plus 4. In that question, they were asking you to try to figure out if there was a pattern with the actual factored expression and the original expression that was given to us. Hopefully we realize that these two terms right here are actually the cube roots of the original terms that were in the expression. And these two terms right here are simply the squares of the two cube roots that we found. So now we can generalize this pattern. So if we have x cubed minus y cubed, where x and y simply represent any term that we have, we know that we can factor this out by finding the cube root first. So we have the cube root of x cubed, which is x, and the cube root of y cubed, which is y, and we simply subtract them. And then inside the bracket, what we will do is we will take the cube roots and we will square them. So we write x squared, and then over here, I'm going to write y squared. And right in the middle, just like we noticed here, we're simply just multiplying the two cube roots. So if we multiply the two cube roots, we end up just getting xy. So we're adding the product of the cube roots. When we're finding the sum of cubes, we actually follow a very similar pattern. We're going to have x cubed plus y cubed. And again, the x and the y just represent terms that we have. And what we will do is we will take the cube root of x cubed, which gives us x, and then we take the cube root of y cubed, which gives us y. And the only difference here is that we just swap the signs. So instead of having a subtraction sign between the cube roots, we're actually going to be adding the cube roots. And inside the next set of brackets in our other factor here, we are going to have the exact same terms, but the only difference will be the sign. So we will still have x squared just like before, and we will still have y squared just like before. And the only difference here is that instead of adding the product of the cube roots, we are going to be subtracting the product of the two cube roots. So we have minus xy. Let's do a small example to figure out how this works. So let's say that I want to factor out the expression x cubed plus 8y cubed. So the first thing is that we recognize that this is a sum of cubes, and that means that we can use the factoring method we just went over. So first I'm going to take the cube root of x cubed, which gives me x, and then I'm going to take the cube root of 8y cubed, which gives me 2y. So now that I have the two cube roots, all I can do is just follow the factoring method that we just learned. So in the first set of brackets, we're going to be adding the cube roots. So we have x plus 2y. And in the second set of brackets, we know that we're going to be having the square of the cube roots. So the square of x is going to be x squared. And then I'm going to square the second term here, which gives me 4y squared. So don't forget that the 2 also gets squared. And we know that in the middle, we are going to be subtracting the product of the cube roots, which are x and 2y. So when we subtract the product of the two cube roots, we end up getting minus 2xy. And we have factored this expression. Let's do another small example. Let's say we have 2 to the power of 3x minus 1, and I want to factor this expression. So hopefully we recognize that both these terms are cubes. And 2 to the power of 3x, it may not be obvious how it can be written as a cube, but we can rewrite it as 2 to the power of x, and this 2 to the power of x is then raised to the power of 3. So now we can clearly see that this is also a cube. And of course, for 1 itself, the cube root of 1 is just 1. So then what we will do is we will place the two cube roots in the first set of brackets. And in this case, we're going to be subtracting. So the cube root of 2 to the 3x is going to give us 2 to the x. And I'm going to be subtracting off the cube root of the second term, which is 1. And in the second set of brackets, I am going to be squaring the cube roots. So I have 2 to the power of 2x. And of course, if I square 1, I just get 1 itself. So I'm just going to put 1 right here. Nothing really changes. And the last step is to add the product of the two cube roots. So now I have plus 2 to the x. And all I did there was just multiply this 2 to the x times 1, which just gives me 2 to the x. And this is correct. All right, we're entering the big leagues now. So let's say we want to factor out an expression 64x to the power of 12 minus 27. So the first thing we should realize is that this is in fact a difference of cubes. It may not be obvious right from the beginning, but if we look at the coefficient of the first term, we know that we can take the cube root of that, and this gives us 4. And if we look at x to the power of 12, we can actually break this down as a power to a power. So we actually have x to the power of 4 raised to the power of 3. So we can see here that the whole term 64x to the power of 12 is a cube. So we take the cube root of 64x to the power of 12, and let's just show the work here. So we know that the cube root of 64 is 4, and we already just saw that the cube root of x to the power of 12 is x to the power of 4. Now let's take the cube root of the second term. This one is going to be a lot easier. So the cube root of 27, I'm hoping that's pretty easy to find out here. We know that that is going to give us 3. Once we know what the cube roots are, the rest of the steps are easier. So now what we will do is we will first subtract the cube roots. So in the first set of brackets here, I am going to be subtracting the cube roots. So I take 4x to the power of 4, and I will subtract off the 3. And in the second set of brackets, what I will do is I will square the cube roots. So for the first cube root here, I am going to square it, and this ends up giving me 16x to the power of 8. And don't forget, I didn't show all the work here, but we got 16 by squaring the 4, and then we got x to the power of 8 by squaring x to the power of 4. And then we square the 3, and this one is a lot easier. If we square the 3, we end up getting 9. Finally, we know that the middle term will be the product of the two cube roots. So what we can do here underneath is just find the product of the two cube roots here. So we have 4x to the power of 4 multiplied by 3. So this simplifies to 12x to the power of 4. So that means that we will be adding the product of the two cube roots. So this gives us 12x to the power of 4. And of course, let's not forget the positive sign in front of the 9. So here is our factored expression. I hope you enjoyed the first video lesson that I made for you guys. I'm still very new at creating video lessons, so I'm always looking for ways to improve. So feel free to give suggestions on how I can improve for next time. Thank you so much and have a nice day.